All right, let's jump right in. Today, we're going to do a super quick masterclass on a math concept you literally use every single day, probably without even thinking about it: rates and proportions. We're going to make this stuff crystal clear.
So, we're going to break this all down using a pretty fundamental lesson, giving you the basic building blocks to start seeing the math that's just, well, all around you. Okay, let's start with a real-world problem. Picture this. You're at the grocery store and you see these two signs for cucumbers. I mean, they look pretty close, right? But is one actually a better deal? How in the world do you figure that out without pulling out a giant calculator? This is exactly the kind of thing we're about to solve. To answer our little shopping puzzle, we need a special tool. It's called the unit rate, and it is all about finding the price for just one of something. So what even is a unit rate? You know, the easiest way to think about it is a speed limit sign. It says 50 kilometers per hour. That's a unit rate. It's telling you the distance for one single hour. The key here, the magic word, is always one. We're looking for the cost per 1 kilogram or the distance per 1 hour. Let's actually walk through how to calculate it. For that first cucumber deal, we start by writing it out as a fraction. You see it there in step 1, with the price on top and the kilos on the bottom. Then for step 2, you just do simple division. Divide the top number by the bottom number. 960 divided by 3 gets you 320. And there you have it. Step 3. Our unit rate is $3.20 per kilogram. And now for the big reveal. If we do the exact same math for the other deal, dividing 1280 by 4 kilograms, guess what? We also get $3.20 per kilogram. So it turns out it was a trick question. There was no better deal. They're exactly the same. That's the power of the unit rate. It's like a secret decoder that lets you compare anything. Okay, now let's build on that idea. When that unit rate, that price per kilogram, stays exactly the same no matter how much you buy, we've stumbled onto something really special in math. It's called a proportional relationship. Now, that sounds super technical, I know, but it's actually really simple. Just think of it like a perfect recipe. If your recipe calls for 2 cups of flour for every 1 cup of sugar, that's your constant ratio. If you want to make a bigger cake, you can't just add more flour. You have to use 4 cups of flour and 2 cups of sugar. See? The ratio, the taste of the cake, stays the same. That's all a proportional relationship is. All right, let's put this new idea to the test with another everyday example. Jonah's looking for a new cell phone plan. We need to figure out which of these plans have that constant recipe, that is, the same exact cost per minute. Okay, here's our data. We've got the monthly cost and the minutes for Plan A, Plan B, and Plan C. So to figure out if they're proportional, what do we need to do? You got it. We have to find the unit rate, the cost per minute for each one, and see if they match. First up, we've got Plan A. We take the cost, $33.44, and divide it by the 220 minutes, and that gives us our unit rate. As you can see, it comes out to just over 15 cents per minute. Let's call that our baseline number. Now let's look at Plan B. We divide the $38 by 250 minutes, and would you look at that? We get the exact same result, 15.2 cents per minute. Okay, so our constant ratio is holding up so far. And finally, Plan C. Let's run the numbers one last time. 36.48 divided by 240, and yep, once again, it is 15.2 cents per minute. So what does this all prove? It proves that the relationship between cost and minutes is proportional across all 3 plans. That constant recipe, our unit rate, is exactly the same for all of them. Now, numbers are great and all, but what if we wanted to actually see this relationship instead of just calculating it? Well, that's where graphs come in. They're amazing because they turn all these numbers into a clear visual story. Okay, here's a new set of data. This shows the number of students per classroom in a school. You can probably see the unit rate right away, right? It's 31 students for every 1 classroom. This is definitely a proportional relationship. So let's see what this looks like when we draw it out. But before we even look at the graph, there are 3 super simple rules to know. It's like a secret code for spotting these things. A proportional relationship will always be a perfectly straight line. It will always start at the very beginning, right at 0, 0. And every single point on that line will have the exact same ratio. And here are those rules in action. Just look at that graph. Is it a straight line? Yep. Does it start at the origin at 0, 0? You bet. It's like a perfectly straight, totally predictable ramp. For every 1 classroom we add, we go up by exactly 31 students. The picture confirms it perfectly. It's proportional. Okay, so We've calculated unit rates, we've graphed straight lines, but let's bring it all back home. Why does any of this really matter? Why is it so important to understand? Here it is, the main takeaway. This isn't just some abstract math you do for a test. Understanding proportions is honestly like having a superpower for making smarter decisions in real life. It helps you find the best deal at the store, scale a recipe up or down perfectly, manage your budget. It even helps you understand gas mileage in your car. So I'll leave you with this final thought. Now that you know what to look for, that constant rate, that straight line starting from zero, where else are you going to see it? As you go through your week, pay attention. In the kitchen, on the road, when you're looking at your finances, you might just be surprised how often this math is quietly helping you navigate the world.